All right, now I finally want to talk to you about the course project. So this document that I'm going to show here is possibly different from the one that I'll give to you, maybe slightly. So maybe don't rely on what you're seeing here, but I'm just going to point to it for to have something to point to. So the project is going to have 5 components. First, a proposal where you describe what system you want to study. So for your project, you're going to go and have to choose a system. So it'll be a system where, kind of like the ones we've been studying, where there's, the system can evolve in time, and the system's state can be described by one number, and you can call that number x of t. The way in which the system evolves in time can be possibly described by a differential equation. Maybe a really complicated one, maybe a simpler one, depending on how many simplifying assumptions you make. And the goal is to, make enough simplifying assumptions that your problem becomes tractable. And what you'll do in your proposal is just describe the system and explain why you think it's a tractable problem. Okay, so that's one component of the 5 components of the project. Each component has a different deadline, so the proposal will be due at the end of week 4. And this is not that much writing, so the proposal is like 1 paragraph is expected. In the end, when you put everything together, the final write-up sort of combines everything, and that should be around 2 pages. That's kind of what I'm expecting for the amount of writing. So this is not really a huge project. Most of the effort will be going into picking something that works and thinking about how to get, depending on your level of proficiency with coding, maybe most of the work will be there, maybe most of the work will be here. I don't know. So anyway, the next part is the theoretical analysis, where you will solve the differential equation, possibly, if you can, or if you can't, do something else to analyze it. So hopefully what you would have done in your proposal is explain why you think there's something that you can do. In the theoretical analysis, you do it and explain what you did. Show what you did and maybe put some plots or something. So that will be due at the end of week 5. Then the numerical analysis, that'll be due at the end of week 6. So there we'll discuss how to do numerical analysis later. We'll do like the simplest kind of numerical analysis that we can do. And so that's 3 parts of the project: proposal, theory, and numerical. Then the remaining 2 parts are your final write-up and your presentation. So the final write-up, that's due at the end of week 9. And for that, you're just going to combine what you previously had. So your proposal, that can be reworked into being an introduction. Then your theoretical analysis, and then your numerical analysis, with possible modifications, because those will be graded and you'll get some feedback on them. So you might want to change them up for the final write-up. And then you'll also add something to the final write-up, which is a bit of a deeper analysis. And you can choose what kind of deeper analysis you want to do. Either make the theoretical analysis deeper or the numerical analysis. So that will be an additional section where you dive deeper into something. Okay, so that's up to you which one to choose. And finally, there's a presentation. So those presentations will occur during weeks, possibly week 9, and definitely during week 10 and the finals week. Each of you will give 1 presentation. So yeah, I think that's about it. So I'm going to give you, I haven't written this portion here yet, but I'm going to give you like a whole bunch of suggestions for where you can find maybe some ideas for systems that you can study, and maybe I'll give suggestions for some systems that you could choose for your project. I actually recommend picking something that's relevant to your major. I think probably every single major that there is in this course has some kinds of differential equations involved. If you want to, force it, then you can make it be there. Also, one idea is that if you know someone in your department, like the department of your major, who does applied work, then like applied math work, then maybe you can actually contact them and get an idea for a really simple differential equation that they have worked with, that they think is relevant to your field.